So in this lecture, let us see about a DFA construction problem using the method cross product or Cartesian product. Okay, so in this lecture, I'm going to solve some problems using the method cross product. You can also say it as Cartesian product. Let us go to the problem statement. So before getting to the problem statement, how can I identify the cross product problem? Okay, so in this problem statement, I'm going to design a DFA which accepts the language which has the uh, both even number of zeros and even number of ones. Okay, so your problem statement is what? So you are going to construct a DFA which accepts both even number of zeros and even number of ones. You can identify in the word here and, right? Yes. So here the two problem statements are joined with the term and. So this is the way of identifying the cross product problem. Okay, for this problem, we are going to draw DFA using cross product or Cartesian product. Okay, so uh, first, the first solution. So in this problem statement, the case is number two cases are there. The first case even number of zeros, okay, and the second case even number of ones. So first I have to draw DFA for even number of zeros. Okay, so this is the DFA for even number of zeros. Second, I want to draw DFA for even number of ones. Okay, separately we have draw the two cases. Okay, so what's the first case? Even number of zeros. So this is the this is the DFA for even number of zeros. So for even number of zeros, actually what is the language for even number of zeros? So in the language it starts with epsilon. Okay, so in the previous lecture I have already told about epsilon, in which cases you should add epsilon. Then I already told in the previous lectures. Okay, so even number of zeros. The even number means it starts zero cases also included. So epsilon. Then 0 is accepted. Then 1 0 1 0 is accepted. So number of 2 or number of zeros 4 6. So these cases are also included in the language. So definitely it is being a infinite language. Okay. So based on this language, so just to draw the DFA. So this is the DFA for even number of zeros or counting zeros, and this is the DFA for even number of ones. Okay. So the same thing. So the language should start with epsilon. So then 1 1. So 1 0 1 0 0. So then it will also it is being also a infinite language. Okay. So for the cases epsilon, if any language starts with epsilon, means you should make your starting state as final state. Okay, so on these cases, your starting state will be playing a dual role, both starting state as well as final state. So for the cases which starts with epsilon. Okay, so this also I have already told in my previous lectures. Okay, so what is the cross product means? I am going to combine these two DFAs and making a single DFA. So apply cross product means the number of states for the first one A and B. Okay, number of states for the second one C and D. Okay, so your states are you don't repeat the state names, making every states with different names. I am using here AB for this here AB, and here I am using CT. Okay. So number of states in the first automata, this is number of states in the second automata. Just cross product means A multiplying with C, AC. A multiplying with B, AB. B multiplying with C, BC. B multiplying with D, BD. Okay. So this is the new states derived from the existing two automatas. Okay. So you are going to draw DFA based on these states. So before that, I'm just making one clarification. I'm taking first AC. So on A on receiving 0, it moves to the state B, and C on receiving 0, it moves to the state C. Okay, then um, C on receiving 0, sorry, here, once again I repeat, A on receiving 0, it moves to the state B. C on receiving 0, it moves to the state C. So, here is new state BC, which is already presented in the cross product answer. Yes. So, this is the way of just checking your uh, um, checking your automata. So, the new generated states are already presented in already presented in the 4 cases only. Okay. So, this is the optional one. So, I'm directly going to the automata. So, first I here in this automata, A is the A which is played both starting state and final state. In this automata, C which is played both the role of starting state and final state. So AC on states it's there. So I'm making this AC state as starting state and final state. Okay. So, first AC I write out here. Then AD I will make it as below to AC. You can so your automata, the states are in any order. Actually, the order doesn't matter. So here, why I am making AC. This is actually a starting state, and just add AD before AC, which means the perfection, the looking. It look very nice. Okay, so that is why I am adding just AD with just below to AC. So it looks very perfect look. It gives a perfect look. That's the thing. Then so BC is added here, BD is added here. So then A on A receiving 0, it moves to B. C receiving 0, it moves to C. Okay, so yes, it is right. B receiving 0, it moves to A. B receiving 0, it moves to A. Right. C receiving 0, it stays in the same uh, then the C receiving 0, it moves to the C. Yes. Okay. So everything is perfectly worked. So A on receiving 1, it moves to A only. A on receiving 1, it moves to A only. Okay. Then C on receiving 1, it moves to D. So AD. So AD. Okay. So then B on receiving 1, it moves to B. B on receiving 1, it moves to B. Then C on receiving 1, it moves to D. Then BD. Okay. So everything is perfectly worked. This is the answer for this diagram. Then yeah, so what's the next step? You have to you have to write the transition table from the transition diagram. Okay. So these are all the number of states AC, BC, AD, BD. So AC, which is the starting state as well as final state. So this is your input symbols. So this is your answer. Okay, the first problem is over. So let us move on to the second problem. Okay. So here we are going to construct a minimal DFA which accepts set of all strings over the alphabet A comma B, in which number of A's are divisible by 3 and number of B's are divisible by 2. Okay. So here A's are divisible by 3 and number of B's are divisible by 2. So, for this case, you should apply cross product. Okay, for your construction DFA. Okay, so how can you identify this problem? So this problem also this problem is also having 2 cases. First one, A's are divisible by 3, and the second one, so now B's are divisible by 2. So you are going to draw a separate automata for these 2 cases. Let us take first case, A's are divisible by 3. So here I have written the language for the A's are divisible by 3. So divisible by 3 means the same and the modular division. So number of A's. Okay. So number of A's modulo division of 3 equal 0. Okay. Actually, so A's are divisible by 3, which is equivalent to this. So for these cases, I have already told in the previous lecture, for these cases, you should add epsilon in your language. That is why I am starting with epsilon here. For so epsilon case, so epsilon, so number of a is 3, number 3, it may be 3 or it may be 6, it may be 9. So these things are accepted. So you won't bother on B can be in any count. So if your language is starting with epsilon means make your starting state as final. That is why I am making here a starting state as final. Then this is the automata for A's are divisible by 3. Okay, just to check A, it moves to Q2, A from Q2 on receiving A, it moves to Q3, and from Q3 on receiving A, it goes to the final state. Yes. For B, A, B, A, A, B means B, A, B, A, A, then B. So acceptable one. This is the case, and this is the case for B's are divisible by 3. So this is the language. So this is equivalent to the number of B modulo division of 2 equal to 0. For this cases also you should start with epsilon. So making my first state as starting state as final state. This is the case for epsilon cases. So this is the automata. So here the states are not repeated. So unique states are using to differentiate between these two automatas. So I'm choosing here Q4 as, for the final state, first starting state, and Q5. So here number of B's, the count of B's are 2, 4. So these cases are acceptable one. So apply cross product. So number of states in the first automata Q1, Q2, Q3. Number of states in the second automata Q4, Q5. This is cross product means Q1, Q4, Q1, Q5, then Q2, Q4, Q2, Q4, Q2, Q5, then Q3, Q4, then Q3, Q5. Okay. So for this cases also your states are be in any order in your constructed DFA, but for making a perfect look I'm just adding like this Q1 Q4. This is the our starting state. Just I am adding Q1 Q5 in just below to the Q1 Q4. Okay, this is the perfect, it will gives a perfect look. Let me check. Then first on receive, see what's your input symbols, A and B, right? So on receive Q1 on receiving A, it will move to Q1, on receiving A, it moves to Q2. Okay, then Q4 on receiving A, it moves to Q4. Okay, so this is A. Next, Q1 on receiving B, it moves to Q1 state. Q4 on receiving B, it moves to Q5 state. Q1, Q5, B here. Next, Q2 on receiving A, it moves to Q3. Q4 on receiving A, it moves to Q4 only. So okay, this is state A. Then Q2 on receiving B, it moves to Q2 only. Q4 on receiving B, it moves to Q5. Then Q2, Q5. This is B. Then Q3 on receiving A, it moves to Q1. Q4 on receiving A, it moves to Q4. Q1, Q4. So this is the A case. Q3 on receiving B, it moves to Q3. Q4 on receiving B, it moves to Q5. Q3, Q5. Q3, Q5 here only. Then Q1 on receiving A, it moves to Q2. Q5 on receiving A, it moves to Q5 on receiving A, it moves to Q5. Okay. Let me check. Q1 on receiving A, it moves to Q2. Next, Q5 on receiving A, it moves to Q5 only. So Q2, Q5. So for this, here will come this. Q1 on receiving B, it moves to Q1 only. Q5 on receiving B, it moves to Q4. So, sorry. So this is the way of the perfect loop. This also came like this only. Q2 on receiving B, it moves to Q2. Q5 on receiving B, it moves to Q4. Okay. Q5 on receiving the it moves to Q4. This also, and this will also come like this. Q2, Q3 on receiving the it moves to Q3 only, and Q5 on receiving the it moves to Q4. Q3, Q4. Okay. For A cases, it will come like this. From Q3 on receiving A, it moves to Q1, and from Q5 on receiving A, uh, it stays in the same state, Q5, Q1, Q5. So this will come like this. Okay, so this is your perfect automata, uh, that is deterministic finite automata for this problem. So what's the next step? Just your write the transition table. So as usual thing, then this is the state Q1, Q4, then Q1, Q5. Actually, 6 states are there. Q2, Q5. Okay, Q2. Then this is Q4, Q5, Q3, Q4. Next, Q3 and Q5. So this is the final state. Then uh, A and B. Okay. So Q1, Q4 on receiving it moves to Q2. So only one I will make it as. So then on Q1 and Q4 on receiving it moves to Q1, Q5. Okay. This is the way of fill the transition table. So we have to, so remaining things we have, so we will cover the remaining things. Okay. So this is the second problem. It's a very important problem. Both first and second, both are very important problem in your Anna University, based on your Anna University syllabus. Both are very important cross product problems. Okay. See you on the next lecture. Thank you.